we're sitting here, and again, the difference here is we've got an initial condition in this problem here. So again, thinking back what we did with the velocity and acceleration problems, when we had an initial condition, we were able to solve out and come up with the exact equation that would have that exact velocity and that exact position at a certain time. So similar thing here. Well, we start off again, just like we've been doing, we're going to separate variables. So y dy is equal to x dx, and I'm going to go ahead and take the integral of both sides. I think by now y'all have seen that that's the pattern that's developing. All right, so what is the antiderivative of y dy?
1/2 y squared.
Okay. 1/2 y squared equals
1/2 x squared.
close?
Plus c.
Plus c. All right. Okay. Everybody okay here? All right, now, again, trying to get y by itself, so we want to square both, take the square, no,
1/2.
let me multiply by 2 on each side, right?
Yeah.
Okay, so y squared equals x squared plus c. All right, now we want to take the square root of both sides. So we get y equals to plus or minus the square root of x squared plus c. Any question there?
Why is it plus or minus again?
In an equation, when you introduce a square root into an equation, you have to assume that it could be the positive or the negative of that value. It's like if I have x squared equals 4, then I know that 2 squared is 4, but also that negative 2 squared is 4. So the way I do it is just say it's plus or minus the square root of 4, and that takes care of it, right?
Yeah.
Okay, same difference, just got those variables there. All right, so at this step right here, I want to introduce my initial condition in there. So it says y of 1, that should not be y sub 1. That's y of 1 equals negative 4. So, negative 4 equals to plus or minus the square root of, not this, squared plus a constant. Okay, everybody okay there?
I thought it's just 1. I mean, it's the same thing. Because y equals y.
Yeah, negative 4. I was right the first time, I just second guessed myself. All right, now, what we're trying to do is we're trying to find the exact equation that has this as its derivative and that as its initial condition. So, from this, we want to square both sides, right? Because we're trying to solve for this constant. So when I get this, I get 16 equals to, this is negative 1 squared, which is b1, right? So just 1 plus c. So c is going to equal to what? 15. Now that's my c value. Now, from here I go back to this equation right here, where I have y equals to plus or minus the square root of x squared plus c, right? Except this c is now 15. But this is not my answer.
Still put -4
Say that again.
Put -4 back into y.
Yeah, the only way I can get negative 4 as my answer is if I do the negative of that square root. So because y is negative, then the solution should be y equals to the negative square root of x squared plus 15. Does that make sense? So this would be your solution. Yes?
So whenever y equals, it's gonna be what we take, so like, because it's negative, it's gonna be negative, and then if
Okay.
it's positive, it'd be positive.
Great question. In a square root problem, yes. Sometimes, and the question asked is it because this is negative that this is negative here? For the case of a square root problem, yes, that is true. But sometimes, like if you take your antiderivative and you end up with a quadratic here, then the quadratic doesn't matter. It's you're just going to write the equation down as it is. It's just a situation here is because I got multiple equations here. So this came from something that was not a function. But I made it a function when I just took the negative square root part.
So it only applies to square roots.
So does this only apply to square roots? No, it would apply to a fourth root or a sixth root or something like that. No, I'm not trying to be smart. I can't think of another instance where you would eliminate the negative, but in an exponential equation, and we'll have some exponential equations, if you ended up with a negative there, then there'd be no solution, because you can't have an e to a x value and it become negative. So there are other things that could happen. So yeah, you do have to weigh into consideration what this initial equation looks like. Less about what this looked like, more about what this looked like. And okay, how do we handle that? All right. So let's do yes.
I just put negative 1 for x.
It should have been 1, thank you. Fortunately, it didn't change anything, but that should have been positive 1. Thanks. Any other question there? Yes.
Why is it 1 and 0?
That's going to be given to me in the problem. This was all part of the problem. So it's not just something I came up with. Great question. The question was, why was it 1 to begin with here? Well, it was 1 to begin with because that's what they told me in the initial problem. All right. So let's just go with dy dx equals 2x squared y squared. And we're going to say that y of 0 is negative 3. Well, again, what do we start off with? The first step is separate the variables. So dy over y squared equals 2x squared dx. So y to the negative second dy equals, and I'm going to pull the 2 out in front of the integral. So it's going to be x squared dx. Don't have to. I just did. All right, so what would happen next here?
Take the antiderivative.
Okay. So this would be,
Negative y to the negative 1.
and I'm gonna multiply both sides by -1.
So can you just do that again?
Say that again.
Can you just swap the numerator and denominator next? To get rid of the negative, to.
Exponent here?
Yeah.
Yeah. So that's what's gonna happen here. We get 1 over y is equal to negative 2x cubed plus c over 3. Right?
Is C always over 3?
Say that again.
Is C always over 3?
It's plus c what?
Is C always over 3?
No, it was not always over 3. Is that what you're asking me?
Yeah, because, well, oh, yeah.
It's just, if I got a common denominator, this would be 3c over 3,
Okay.
and 3 times a constant's a constant.
Okay.
Is that do y'all follow that? Okay. So now, if I solve for y, I just take the reciprocal of both sides. So y is going to be 3 over, or -3, I can do that. So let me mark it off like that. It's all the same thing. So -3 over 2x cubed plus c. That is the ugliest 3. Okay. So that is my antiderivative. This right here, if you could do this on the AP test, that's typically 5 points. And it's not, like I said, it's not 5 hard points. All right, so now what am I doing next?
Plug in.
For x and setting it equal to 3, right? Or -3. So -3 equals -3 over c. So c would equal to -3 over -3. So c equals 1. So my final equation here is y equals -3 over 2x cubed plus 1.